Hello and welcome to the Stack Tech Bench. This is Joseph Stackhouse, and today we're going to be doing a tutorial on the TinyDuino Wi-Fi TinyShield. If you're familiar with the TinyDuino platform, you'll know that it's a very small Arduino platform. It all connects in a modular fashion using this standard connector. Get the camera to focus here. And as you can see, it's approximately the size of a quarter. This is the TinyDuino itself, not the Wi-Fi module. I'm just showing it for reference. Here is the Wi-Fi module. It's about the size of my thumb. It has a Texas Instruments CC3000 chipset on board that supports 802.11b and 802.11g. The authentication types that it supports is WEP, WPA, WPA2. I do believe it supports TKIP and AES. It can have up to 4 concurrent sessions or sockets, but it does not support being an access point or an AP mode. So if you need a project that you need to create your own access point, this would not be good. Otherwise, you're good to go. It uses about 275 milliamps of power. You can't use a coin cell battery with this module, as it does drive a little bit too much power. You'll have to find a larger battery or a different power source to power your project. It has a shutdown mode. In shutdown mode, it only uses approximately 5 microamps of power, which is not bad at all. It has a voltage regulator and level shifter built in, so you can use it doing 3 volts or 5 volts in your project without having to worry. It uses SPI communication, not UART, so you can push data to and from it really fast or really slow. It's kind of up to you. It has a interrupt system with an IRQ pin, so you can actually have asynchronous connections. The unit itself measures. I got the calipers out and measured it. This little baby is only 20 millimeters by 36 millimeters by 5.11 millimeters. It's very thin. And I'm going to go ahead and snap it into the actual TinyDuino here so you can get an idea of what size we're talking when they're together. Okay, there we go. And in comparison, here's the size of my thumb. Not that I have fat fingers, but you see very tiny footprint. I can see multiple uses for this Wi-Fi module. You could use it in a quadcopter, you could use it to track something. There's all sorts of uses in the tiny footprint. It gives you plenty of room for a high-powered battery, for instance. To give you some long run times on it. Okay. I'm going to go ahead and start the tutorial on this. We're going to head over to the computer and look at some code. I'm going to assume that you already know how to use the TinyDuino and that you've actually uploaded sketches to it before from the latest version of the Arduino IDE. We're going to be using the USB ICP board that also snaps into the TinyDuino, so we can hook it up to a USB cable to actually program it. And we're going to use the adafruit CC3000 library. There was already a very well written library, so that was used. And the only thing we'll have to do is change some of the pin differences in the adafruit library, since we're using our TinyDuino's universal bus here. So we have to explain to it what the actual pins used will be. So we'll take care of that as well in the code. And the simple project that we're going to do is simply going to connect to the internet. It's actually one of the Adafruit examples. And all it's going to do is find a time server out on the internet, and it's going to pull down the current Unix timestamp, which is the number of seconds since some date in 1970, which you can use to then tell what time it is. It's a good way to get the time when you don't want to spin some extra code, or include a crystal in your project to keep track of time. That can be kind of a pain for those of us who have done it before. Alright, we're going to head over to the computer now and check it out. Alright, our first stop is going to be the Tiny Circuits website. You can find it at tiny-circuits.com. You're going to want to go over to the Learn section of the website. Down on the page, you're going to want to find the Wi-Fi TinyShield section. Most of the information here I've already covered, but it would not hurt for you to read all of this. It goes in some more detail on what pins are used and what not. I'm going to show you how to define those pins in the demo that we're going to use from the Adafruit CC3000 library. If you scroll down on the page a little farther, you will find the CC3000 library page. Once we're here on the page, you're going to want to go to the Using the CC3000 link, and you will find the GitHub repository page for the library, or you can use this download button here that will download the latest library. As you can see, we have the zip file here. You're going to take this whole folder and move it into your Program Files Arduino library folder. Which yours is probably C, Program Files, Arduino, and then the version. Mine's in a different location, but you shouldn't have a problem finding that. It's very easy. Alright, as you can see, there's the Libraries folder. Once you get into the Libraries folder, you're going to want to paste it in here. I've actually renamed it. It had quite a long name, so I just renamed it to adafruit_cc3000. Okay, now that we've got the library, the CC3000 Adafruit library in the Arduino folder, library folder, we're going to go ahead and launch the Arduino IDE. To check that the library has actually been installed correctly, you're going to want to go to the File, Examples, and you should see the Adafruit library shown here. If you do not see it here, it did not get extracted correctly, and you're going to want to attempt to do it again to get it to show up. We're actually going to be using the NTP test sketch in this example. However, feel free, once you're used to defining the pins that the TinyDuino will use to communicate with the Tiny Wi-Fi shield, you should definitely test out some of these other examples. They're very cool, very useful, and they'll give you some good ideas. So we're going to go ahead and open up the NTP test sketch. As you can see, here are the pins defined. I'm going to go back to the Tiny Circuits webpage. And we're going to scroll down on the page, and you'll find the pin definitions for the Tiny Circuits Wi-Fi TinyShield. These are the pin definitions you're going to have to replace in the CC3000 Adafruit library, as it's designed for Adafruit's own CC3000 breakout board. So what we're actually going to do is we're going to leave these pages side by side so we can see those pin defines instead of pasting them in. So we're going to find the IRQ, Adafruit_CC3000 IRQ. The default library setting is 3. We need to change it to 2. The VBAT setting, as we can see, needs to be changed to analog 3, A3, instead of 5, which is what it was. And the Adafruit_CC3000_CS needs to be changed to 8 from 10. Once you've made those changes, you'll be good to go. The only other changes we'll have to make is your wireless LAN SSID, your wireless LAN's SSID password, and the security mode. I'm going to be testing this using an SSID I'm going to create just for this example. And we're going to be using WPA2 encryption. Alright, this is my access point, my wireless router settings. I'm just going to show you that I quickly set up an SSID called TinyDuino. It's in WPA2 mode, and I've set the access key to just be Tiny Wi-Fi all lowercase. Go ahead and minimize that. I'm going to come back here and put those settings in. You're going to want to put your settings, of course. TinyDuino. And our password is TinyWiFi. Alright, I've went ahead and connected my TinyDuino to the USB ICP interface board, so it's now connected to the USB cable, and the Wi-Fi shield is then connected on top of the USB ICP board. So we can now make sure, if we go to Tools, Board, you'll know the TinyDuino needs to show up as a Arduino Pro or Pro Mini, 3.3 volt, at Mega 328. We have that option selected. And go ahead and make sure my COM port is okay. I'm going to go ahead and upload the sketch. This may take a little bit of time. It is quite a large sketch. You've got a lot of library there in the Adafruit CC3000. As you can see, it looks like about 30 kilobytes or so of data. The lights are now flashing on my USB ICP board as it programs the TinyDuino. Once it's uploaded, we can go into the serial port monitor, which will wait just a second. All right, we'll go to the serial port monitor, Tools, Serial Monitor. You're going to want to make sure the baud setting is 115200, otherwise you'll get some binary printout on your screen. That's very important. That's the default that the Adafruit library uses to communicate. As you can see, the Adafruit library demo for the NTP setup spits out a lot of good information here. You can see the free RAM initializing the chipset, the firmware version of the chipset. It deletes the connection profiles. You can see all this in the code. It's commented pretty well. It'll attempt to connect to our SSID that we configured earlier, the TinyDuino SSID. It connected successfully. It requested a DHCP address, and then it sent out the request for the NTP to the NTP server to grab the current time. You can see all this in the code down here. I'm not going to go too much in detail, as this is just a tutorial to get you up and running so that you can successfully get your TinyWiFi shield to work. You can see it connects to time.nist.gov, and there's some additional defines here to actually parse out that Unix timestamp into a month, day, year, and timestamp. It's a really good example. It's the best one I could think of to give you a quick up and running feature to show you how easy it is. The whole process when I took the TinyWiFi shield out of the package took me literally under 3 minutes to get it working and send receiving data, which I've used other Wi-Fi shields in the past and always had issues. The Adafruit one is great, and so is the TinyWiFi shield. I hope you enjoyed this demo. I hope it gives you some good ideas of what you can and can't do. You could also use this shield in conjunction with the TinyGPS shield, which I will be covering, I do believe, in the next tutorial, if not the one after the next tutorial. Leave me some comments if you appreciate this video. I really would love to see them. If you have any questions, you can also leave those, or you can head over to the Tiny Circuits forum, and there's some people there that will also help you. All right, thank you again. This is Joseph from Stack Tech, and I hope you enjoyed this video tutorial.